So if you were with me in the last video, I basically gave an overview of the three types of transformations that we will be doing in this course. And they are reflection, stretching, and translation. First, I'm going to focus on reflection. So like I said before, there are two types of reflections. So there's a reflection across, one is known as a vertical reflection, and the other one is obviously known as a horizontal reflection. The first one we're going to focus on is called a vertical reflection. And what it is that, let's say if you have a function, let's say if you have a random point, okay, let's call that point 2, 3. Sure, let's just say we have 2, 3. A vertical reflection means that what we're going to do is we're going to reflect it across the x-axis. This right here is the x-axis. So what we're going to do is reflect, this is known as a reflection across the x-axis. So for example, if this point here, 2, 3, reflects across the x-axis, the new point after it has been reflected will be, well, the x values basically stay the same, but the y value will now change to -3. So effectively, the vertical reflection, it affects the y's, it affects the outputs, but it doesn't change the inputs. So the thing to remember is vertical reflections affects the output, in other words, the y values, but not inputs. In other words, the x values. So it affects the outputs, the y values, but not the inputs. And the way we write this, the way we write a vertical reflection, it looks like this. So say, for example, if we have an original function f of x and we transform it with a vertical reflection, the transform function looks like this: y equals -f of x. So let me explain why. So if we, as we said over here, it affects the output y, but not the inputs x. So if you look over here, if you look in this expression right here, the inputs are not affected. There's nothing happening to it. There's no number or negative happening over here. But the y's, on the other hand, oh, I probably should have written this. So y equals f of x. So this is being transformed to that. So, but the y's, on the other hand, all become negative because of that negative there. Let me just use white to explain that. So they all become negative because of that negative over there. And as we can see, this 2, 3 becomes 2, -3, meaning only the y's changed. So let's do this using an example. So this was a function that I told you to write. If you haven't written this down, then what I would like you to do is pause the video and copy this function down. Again, there are 3 points on this function. So they're here, here, and here. And I've basically written an XY table stating those coordinates. So in other words, this is 1, 2, 2, 4, and 4, 1. And again, we will be using this example throughout. We're going to be transforming this many times. So let's say, for example, I do a reflection across the x-axis. So let's say I write y equals, so here's f of x, and I do a transformation. This is the transform function, equals -f of x. Well, first of all, if I ask you to describe this transformation, you're going to write simply a reflection across the x-axis. So even though the y's change, remember that it's a reflection across the x-axis. So in other words, all these points will be reflected across this axis. And so like we said before, this affects the y's, but it does not affect the x's. So this xy belongs to f of x. And if I transform the function, to -f of x, well, how does that change the xy table? Well, let's just see. So I'm going to write this in green just to, so the x's stay put, but the y's now become negative. So if the x's stay put, this still becomes 1, 2, 4. I'm just literally copying down what I've written here because the x's don't change. But the y's, as we've stated, will become negative. So this will become -2, -4, -1. So all the y's change. So what we're going to do here is we're going to plot these set of points and see how the transformation looks like. So so now we have 1, -2. So let me just make these 1, 2, 3, 4. So this point is -1, -2, -3, -4. So let's look at the coordinates. So 1, -2 is right here. 2, -4 would be 2, -4 would be right here, and 4, -1, 4, -1 would be right there. And if I draw a line between them, let me just do that. Let's use green. So if I draw a line between them, that's what the transform function looks like. And let's label this transform function. This transform function is simply -f of x. And as we can see, this function has been reflected across the x-axis. In other words, we've done a vertical reflection, but remember, the proper way to write it is to write it's a reflection across the x-axis. And again, how do we know if there's a reflection across the x-axis? When you see a negative outside of the f. It's not inside the f, but outside the f. Really, really important that you note that the negative, in order for a reflection across the x-axis, is outside of the f function. I'll see you in the next video to talk about horizontal reflections.